last several days, some of last week, you need to, I have recorded lessons. So all you got to do is go on my homework page and look at those lessons, same as this. Everything that we've done, I've recorded. I think it's the last week, at least the last week, but it's all on my homework page. So you should be fine. What kind of angle is that first one at the top? How do you know? Okay, this one has a right, it has the box, so it's a right angle. Do you guys agree with that? Yeah? What about the one that's 150 degrees? Why? It's over 90 degrees. Okay. What about the 40-degree angle? Acute. It's a cute little angle, right? More than 0, less than 90. And you've known all of that since elementary school, correct? Okay. Now, how do we find the perimeter? Daniel, how do we find the perimeter? All right, so we're going to take all the sides, and we're going to add up all the sides. If I can get it back here. So that means I'm going to take 2x plus 6. That's my first side. Write this down if you don't have it. I'm going to take the second side, which is x plus 3. And I'm going to take that third side, 3x plus 8. And I'm going to set it equal to 47. That's how you find the perimeter. If you're finding the perimeter of the room, you're adding up all of the sides. Okay? Pardon me? Let's see. Shouldn't. If we combine like terms, what is 2x plus x plus 3x is 6x. 6 plus 3 plus 8, 17, good, which is equal to 47, right on? Then do what? Minus 17. You got 6x is equal to 30. Aha, it's going to work out nicely. And so x is going to be equal to how much? X is equal to 5. Now, what did the instructions say? Because, see, it said find x, didn't it? And then find each side. So what do we do with that 5? Now we go back and we plug it back in. Okay? Now, this is, what property are we using? Substitution property. Very good. So here we go. 2 times 5 plus 6. 2 times 5 is 10. 10 plus 6 is 16. So this side, excuse me, is 16. The bottom, same thing. 3 times 5, which is 15. 15 plus 8 is what? 23. And then this next side is 5 plus 3, which is 8. Could I make sure? 23 and 16 is 39. 39 plus 8 is 47. So it works out correctly. 24. That's what you should have gotten. Aha. Okay. Found your mistake. All right, questions. Easy so far? All right, and here's the thing. If you don't have paper, there's paper back there. You need to be prepared, okay? When we run out of lined paper, just put it on my desk. When we run out of lined paper, you guys are going to have to start using that blank paper back there. I'm not providing any more paper. I got to provide paper for myself and my own children, okay? Love you, but money tree is not in my backyard. Wish it was. Here we go. I know. I sure wish I had one. All right, so look at what we're going to do. You don't have to copy all of this, but you do have to copy. Today is the 19th. And we are going over section 4.1, classifying triangles. Write that down for me, please. Section 4.1, classifying triangles. And what we're going to be doing today is we're going to be classifying triangles by their sides and their angles. Classifying triangles by their sides and their angles. Very simple. Very cut and dry, okay? But we're going to be classifying triangles by their sides and their angles. Video. Here we go. All right. You got to remember that a triangle is a polygon with 3 sides. That's all you need to write. Polygon with 3 sides. Okay? Triangle is a polygon with 3 sides. Now, we are going to abbreviate triangles with a tiny little triangle. You know how we abbreviate or symbolize the angles or the segments or whatever, okay? All right, so we've got our triangles. That's just a small triangle. What are the sides? Let's label these. I want you to draw this big old triangle on your paper. Label it the way I have it labeled. It doesn't have to be perfect. What are the sides of that triangle? What kind of sides make up that triangle? Hold up. Listen to what I'm asking. Sides are segments or angles? Segments. So, there are 3 segments we're looking for, correct? Why? Because there are 3 sides. All right, so the sides, this is all you got to do. We're going to list the sides. All right, and you told me that the sides are segments. So what's the first side? Segment AC. We'll just start with AC. That'll work. What's the other side? What's another side? AB. CB or BC. It's the same side. It doesn't matter the way you name it. But as long as you name all 3 sides, write this down. Now, there are also 3, write this down. I don't feel good either. We're going to suck it up and we're going to do our job. Okay? Here we go. What are the angles? There are 3 angles. I don't care about what their measure is. I want you to name them. Angle A. What's another one? Angle B and angle C. Right on? Very simple. Vertices. What are vertices? I want you to write that down. Vertices, that's plural for vertex. What's a vertex, y'all? What is it? Say it again. The pointy part. The corner, right? Okay? And the corners, Maddie's already said what they are. It's got to be point, line, or plane. What is it? It's a point. So what are the vertices? Points A, B, and C. Point A, point B, and point C. Right on? Okay? Very cut and dry. Very easy. Okay? Okay? Yep. This is all you got to put here. Acute triangle. You got to draw the picture. Notice that this is classifying the triangles by angle measures. Let's do it this way. Just draw this right here. Make you a list. Angle measures. Okay? It's an acute triangle. How many acute angles are in an acute triangle? 3. Very good. How about this one? What kind of triangle is that, Logan?
Right angle.
It has a right angle in it, so what kind of triangle is it? What kind of triangle is it, Logan? Right triangle. You said it has, how many right angles can it have in it? How many? Just one. One right angle only. The other two angles, just out of curiosity, are what? Can you have an obtuse angle with a right angle? No, they're both going to be acute. The other two angles are acute. Here's one. Don't say anything out loud, just draw the picture. Rebecca, what kind of triangle does that appear to be? Why? It's got one obtuse angle. How many obtuse angles can an obtuse triangle have? Only one. Okay? One obtuse angle only. The other two angles have to be what? They have to be acute. It's not even possible to draw one with more than one obtuse angle. Okay? Are we leaving out anything? We got an acute triangle, a right triangle, and we got an obtuse triangle. What? Maybe. Let's classify by, that was by angle measures. Let's classify by side lengths. Pardon me?
I was going to say what the measure plate the right and I need this is 180.
Yeah, the angles within those triangles are. But we got to now label these triangles according to their side lengths. So let's take the same type of triangle. What do those two marks mean? That means that those two sides are congruent. What kind of triangle has two congruent sides? Warm. Just two congruent sides. Cody, you're very warm. Because an equilateral triangle does have two congruent sides, but that's not what I'm wanting. You're warm. Starts with an I. Isosceles. There we go. Isosceles. That's a weird looking word. It's got two congruent sides. Hey, it's got two S's. Maybe that'll be a nice little. Two sides congruent isosceles, right? What if, now Cody, you said this right here. You said equilateral, and I was going to go there later, but since you had to go there, attaboy, thanks. What's it mean? What is an equilateral triangle? All sides are equal, okay? Three congruent sides. And you got to be kind of particular about this. This is, if I turn that upside down so that it's sitting on the point, isn't that kind of a sign you see on the road? Isn't that the yield sign? Ms. Biggs, aren't you proud of me? But it is. All three sides are congruent, right? Equilateral. Now, I'm going to come back to that in just a second. What about a triangle that looks like this? Oh, that's bad. But let's say this is 11, this is 9, and that's 5. That's supposed to be straight without that little on there. What does it start with? Are we playing charades? Sounds like. Very good, Maddie. What's that mean? Scalene triangle. What do you notice about those sides? No congruent sides, right? No congruent sides at all. All of the sides are different. Fácil or difícil? Muy fácil. See? All right. Now, Cody went there. He had to go there. Thanks, Cody. Why do you think we got to revisit equilateral? We are going to find the side measures.
But on that it'll be easier. If you find one, you find them all.
You find one side, you find them all. You're exactly right. How about this? If all the sides are congruent, an equilateral triangle, folks, if all the sides are congruent, will anything else be equal? All of the angles have to be congruent. So if I were to draw these little marks in here, an equilateral triangle is also called it is an acute triangle, but to be more specific, it's called an equiangular triangle. But doesn't that make sense? What does the prefix equa mean? Equal. Angular would mean, of course, angles. So, an equilateral triangle is also called an equiangular. And it doesn't matter what you call either one of them. All three sides are congruent. And what else? All three angles are congruent. Let's see if y'all see what you know about this. What? It's the band outside. The high-pitched noise. It did. Awesome. Because only dogs can hear things like that, Kevin. I'm just saying. Okay, if y'all start barking at me, if you start chasing me or cars down the road, if you try to bite my ankles, I'm gonna get you. All right, now I'm gonna kick you. Is what I'm gonna do. What are the angles equal to in an equiangular triangle? What are each of the angles equal to? They are going to be the same, but what will they be? Anybody have any idea? What will their measure be? What will their degree measure be? How do you know, Smarty McFarty? They're 60 degrees each. Write that down. Because 60 times 3 is 180. Very good, sir. How'd you know that? How do you know that? 180 divided by 3 gives you 60. Because if you were to add up all the angles in the triangle, they're equal to 180 degrees. Okay? Now, they should what? They should equal. Because look at the prefix of the word. What's it mean? Equal. Everything's equal on that triangle. Okay? All right, so what's next? Let's look at this. We've done that. We've done that. Let's look at this triangle. Folks, I want you to draw this. I want you to write the instructions. Draw the picture. That shouldn't be there. There we go. That's the way to get rid of it. I don't know. It just went away. BDC. First of all, where is BDC? It's right here. It's not the whole thing. Excuse me. And you got to be real careful about that. Now, okay, you got to be able to Notice. Yeah, perfect. Yeah. You got to be able to see it. And folks, look what I had to do immediately. Without even approaching the problem, without even answering, what did I do immediately? I had to draw in, I had to color in or highlight what I'm looking for, right? I have to do that. And you guys see it, and I do it, and I don't even realize what I'm doing, okay? But look at what we have. We got a 90-degree angle right here. How do I know that's a 90-degree angle? Because there's a box. And there's this little tiny little piece right here that's 20 degrees. What's this piece have to be? Why does it have to be 70, Lauren? If this little piece is 20 and the whole thing is 90, then this piece right here has to be 70 degrees. So what I'm actually looking at, I want you to draw this, is I'm actually looking at a triangle that has 100, 70, and 10. That's what I'm looking at. Now, classify that by its angle. Is that an acute, an obtuse, or an equiangular? Why is it an obtuse and not an acute? Because 100 degrees is an obtuse angle. Okay, that right there makes this, and look at me, an obtuse triangle. Write that down. Okay? Whoops. Yeah. No, I'm not. I don't even care about the sides yet. If we were, then yeah, it would be scalene because, and you're not supposed to know that already. But yeah, it's going to be a scalene triangle. If all of the angles are different, then all of the sides have to be different. Very good. Let's look at another one. We've already done that. Let's look at this example. Okay. Classify FHG by its angle measures. Folks, just look at it. What's the first thing that I have to do to this? I have to outline it, right? So I've got to find triangle FHG. Right there it is. Now look at that. What do I need to do to that? I'm missing one angle measure. What is it? Why? Because it's, how do you know it's equal though? What were you going to do mathematically? 30 plus 60 equals 90. Do y'all see my red box right there? I just made it into a green box. All right, so it says classify it by its angle measure. 60, 60, 60. What kind of triangle is this? It is, but give me a better answer. Why is equiangular a better answer? It is angles, not the sides, but it's more specific. Okay, it's more specific, and you got to give me the best answer. Okay, got to give me the best answer. Here's another one. Side lengths, we've already done that. All right, let's look at this triangle. EHF. Look how we're, write this. Classify triangle EHF by its side lengths, and then draw this picture right here. Give you just a moment to highlight. I need to highlight triangle EHF. EHF. There it is, EHF. What's two things on there that you notice right off? 10 and 12. Okay, it's got two triangle measures. If I were to separate this, if I were to redraw, but I'm concerned about side lengths, not angle measures. Do I know that that is a 90-degree angle? How do I not know that? How can I not assume that? There's no box. All right, so look at it again. What do I notice about this? The tick marks. Who said tick marks? Very good. Tick marks mean that if that bottom side is 10, what's that upright side? It's also 10. So now I have two sides that are congruent to one another. What's the name of the triangle with two congruent sides? Isosceles. Very good. Do you need to be able to spell that? You should. Yeah, kind of. You need to. Questions at all? Different? All right, here we go. You need to write the instructions. You need to draw this picture. That's supposed to say triangle. See what you can do with that. Do that yourself. ACD. Triangle ACD. We got 5. Hey, what's the mark? What's the side that has that little tick mark? What's its measure? How do you know it's 15? Because it's got 15 over here, doesn't it? Okay? So this little tick mark means 15. So now my triangle has a side length of 5, 15, and 18. What kind of triangle is it? Scalene. Why? Because all three sides are different. They're not equal to one another. How many of you had scalene correct? Hands up. Very good. Very good. Let's move on. All right, let's look at this problem. It says find the side lengths of, well, I'll be John Brown. We're not going to do that. Yeah, we are. Really? Seriously? Okay. Well, let's look at this. Bet you'll never guess what X is. We're going to find the side lengths. Okay? How in the world are we going to figure this out? What do you notice about your picture? It's a triangle. It's small. It's obtuse. What else do you notice about the picture? Oh, it's got tick marks. What do the tick marks mean? The sides are congruent. Which two sides are congruent? The tick mark sides. Name them. JK is congruent to KL. JK is congruent to KL. What did, now go, folks, that's given, right? Isn't that given to us? What property, now let me back up, what definition said that I could go from congruence to equality? Y'all remember that? What definition allowed me to go backwards and forwards between congruence and equality? Definition of congruence, thank you very much. Definition of congruence says that if the segments are congruent, then their measures are equal. If their measures are equal, then their segments are congruent. Very good. That goes for segments, angles, whatever. What is JK? 4x minus 10.7. I'm going to tell you what, y'all going to have fun with this for homework. What is KL? 2x plus 6.3. What do we do now? Plug it what? What? No. Good try. Say it again, Maddie. Subtract 2x from 4x. Because we got to solve this thing, right? And I got 2x minus 10.7 is equal to 6.3. What do I do now? Add 10.7. And that gives me 2x is equal to 17. Here's when you need your calculator, and look how many of us don't have a calculator. Folks, you need to bring your calculator with you every single day. Divide both sides by 2, and I'll be daggone, if we don't get 8.5. How about them apples? Okay? So we get 8.5. Now, are we done? All right, did we find x? Yeah, we found x. That's easy. What's the next part? Plug them in. Now, do I have to plug x in to all 3 sides? Do I have to? No. All right, 2 of the sides are congruent. Now, let's look at this. Folks, this 6 in one hand, half dozen in the other. Doesn't really matter which side we plug into. I'm going to plug in here 4 times 8.5 minus 10.7. You got a calculator, you better figure that out. 4 times 8.5 minus 10.7. You better figure this stuff out with this calculator, y'all. One more time. 23.3. So 4 times 8.5 would be 32, 33, 34 minus 10.7. That is 23.3. Okay? So that means JK is 23.3. What other side is 23.3? KL. And now I got to find JL. How am I going to do that? I'm going to plug it in. 5 times 8.5 plus 2, 42.5 plus 2 is 44.5. You guys agree with that? You agree? Because we're just substituting, right? What could I ask you now? Say what? What are all the sides? I don't really care about the angles. Oh, thinking forward. My next question could be, what's the perimeter? Write that down. How do we find the perimeter? We add all the sides. So I would just add 23.3 plus 44.5, right? All 3 sides. Aha. Yep. What? What? Oh, tell me how to find it, and then yes, you may. 91.1 meters or feet or yards, whatever. How about them apples? Hey, very good thinking thinking ahead. That's where we're going with this, okay? Now, not that we have many triangular-shaped rooms, but it's still applicable to A-frame houses, dog houses, if you only had 2 sheets of plywood. Or how about a playhouse?
Yeah.
I mean, all the boys have playhouses, right? No, boys usually don't have playhouses. Usually it's the girls. It's all good. Or dollhouse. Your dollhouse, right? Your dollhouse. Here we go. Done with this. Done with that. Hold. All right, folks, here we go. Look at that. I want you to, look what it says. Find the side lengths of equilateral triangle FGH. Do you think that's important?
Yeah.
What's important? Ooh, the equilateral part's important. Because that means all 3 sides are the same. And we've got 3 different expressions. They're going to all equal the same number, but how am I even going to begin to figure out what that number is?
Wouldn't that you add them together?
But if I add them together, I got to have a perimeter. Am I given a perimeter? How am I going to find y? You're warm. How are you going to find y? Which is? No, we didn't add together to find y. Somebody said equal. Who said equal? Amber, what are we going to set equal to each other? Because I got three sides with three unknowns. Is 180 dealing with sides or angles? Angles, right? All right, that's a very common thing that we do. We say, oh, it's a triangle, 180 degrees. But listen to what I said, 180 what? Degrees, it has to do with angles. Are we dealing with angles? No, we're dealing with sides. Justin, what do you think? Say it one more time. If we know that all three sides are congruent, does it matter which side I set equal to which side? No. So pick two, any two. Pick a card, any card. The top two, why? They look like they're the easiest to deal with. Why? Because they don't have big numbers. Is it that easy? Absolutely, it's that easy. So we're going to take FG, and we're going to set FG equal to GH. What is the length of FG? 3y minus 4. What is the length of GH? 2y plus 3. Now do we have enough information so we can find y? And then once we find y, what are we going to do? Plug it back in, and we're going to find all three sides, right on? Do it. How do I solve this? Subtract 2y, and then I'm going to add 4. All right, I'm going to do all that in one step. Y is equal to 7. How many of you had y equals 7? Very good, y'all. Now what? 2y plus 3 because it's smaller numbers. I don't blame you. If it were an equilateral triangle, why not choose the smallest one, right? They're all still the same. So 2y plus 3, 2 times 7, which is 14 plus 3, which is 17. Just out of curiosity, hey, it's up here on the board. 3 times 7 is 21. 21 minus 4 is 17 indeed. 5 times 7 is 35. 35 minus 18 is 17 again. Hey, what's a perimeter? How do you know? 17 plus 17 plus 17, or 17 times 3. Very good, y'all. Very, very good. We're not doing this. We're not doing this. We're not doing that. We are doing this. Here we go. Here's what you're going to do for me. You guys did great, because I'm telling you, I'll spoil you when I give you those notes. You better just be ready, and you better get you a gob of paper every day, okay? You're going to do the following problems out of your textbook. Here we go. Page 219. Folks, I want you to do 4 through 7. And then 9 through 11. And guys, number 11, get your books and look at that. That's 7 problems, okay? But I want you to look with me at number 11. This is talking about the, let me see if I can get this up here. Yep, talking about the necklace. Let's look at this real quickly. I just want the book. Nope, not what I want. All right, I was hoping to get that picture snagged. Anyway, look at that picture. You've got a triangular, what? Earring. Everybody in here can deal with an earring, okay? All right, so we got 3 centimeters, and we've got 1.5. You can if you want. You're going to have to write it down at some point anyway. All right, so we got this earring. Folks, just out of curiosity, it says a jeweler creates triangular earrings by bending pieces of silver wire. Each earring is an isosceles triangle. All right, just out of curiosity, this other side has got to be what length? It's got to be 3. Wow. Okay, no, we ain't done yet. Keep looking. It says, how many earrings can be made from a piece of wire that is 50 centimeters long? That's all the wire you have. What are you going to have to do to solve this? Don't tell me the answer. Tell me how you're going to have to solve it, Daniel. Where'd you get 7.5 from? If you add up all the sides, you're going to have 3 plus 3 plus 1.5, which is 7.5. And then you're going to take 7.5 and you're going to divide it into the total amount of wire you have. Yes? This is real life math, folks. I mean, I know all of y'all in here go home and make your earrings. Kevin, right? Yeah, see? So when you're making earrings, you got to know what you got to start with. And how many pairs you can, or how many total earrings you can make, because some people don't have equal number of earrings in each ear, right? So that's how you do that problem.